Okay, so here's some more properties, but these are where we're actually applying some different rules inside of logarithms themselves. So not just like an evaluation, but this is just properties that we can apply to the logarithms. So what I want to do to start off here is that if you think you need to, you can copy down here these rules for exponentials. However, these are rules that we've been using. We have, for example, the rule that says that if we have two things being multiplied together where the bases are exactly the same, then we can take the exponents and we can add them together. So in this case here, product goes with addition. We have a problem that says that if I have some number raised to a power divided by the same number raised to a power, that the division turns into subtraction. So the quotient goes to subtraction. We have a power rule. A power rule says that if I have a number raised to a power, raised to another power, I can take those two exponents and I can multiply them together. And so the power rule is to multiply. And then we have change of base, which we don't use for exponential, only for logarithms. So what I want you to do here is as you think about this kind of historically what you've been doing with exponential functions, I want you to see the connection between logarithmic functions. And so in logarithmic functions, sometimes what happens is that they give us this expression or this statement or equation with several logarithms. And so we call that the expanded form. When it's in expanded form, we want to obviously condense it. And so what we see is that if you have multiplication, it becomes addition. And if you have addition, it becomes multiplication. And so that's that multiplication going to addition. Just like here, if you had a multiplication, you added the exponents. Or if you had adding the exponents, it means you had multiplication. On the next one, same thing, we're condensing on one, we're expanding on the other. But the key thing is that division turns into subtraction, or vice versa, subtraction turns into division. And when we're condensing, we have one logarithm. When we're expanded, we have several logarithms. The last rule is called the power rule, and the power rule says that we'll take this exponent and we'll move it out in front. Now that's not exactly what this one says here, but it's very similar in the sense that you're doing something with the exponent. So if it's out on the exponent, you move it out in front. If it's out on the front, then you move it back up to the exponent. It depends on which one you're looking at. And then last but not least, which we'll have a separate video for, is we have a thing called change of base. So let's just focus on these first three right here. So get those copied down. We're going to use them on several problems. So start off, our first one is that we're going to talk about the power rule. Okay, so this slide is the power rule. And we have two problems that are condensed, and we want to expand them. And so basically what happens is that we have this. We have some log base something of m raised to the r power. So we take that 4, we move it out in front, in an expanded form, it becomes 4 times log base 6 of z. Make sure that 6 is a subscript. Okay, so hit pause, go ahead and do the second one. Come on back. So that would be log base 5 of z. So that will be our expanded version coming from our condensed. We move right along now, and now we're going to go from expanded to condensed of the same rule. So this is still the power rule. So we're starting off with something on the front that we're going to move to behind. Give me one sec. Okay, so now we want to go the other way, and we're still looking at the power rule, so kind of looking at them one at a time. So in this case here, we see that we have a logarithm with a base and an argument. And we want to take that power, that number out in front, and we want to move it. So we essentially want to take this number out in front and move it back on the argument. So this would be log base 5 of t to the third power. Go ahead and do the second one, hit pause, and then bring it back on. So same deal, we move the 30 up. So this becomes log base 4 of y to the 30. Now remember, this is the power rule. So now let's move on to the next rule. So now we're going to take a look at the product rule. So in the product rule, remember that we have, if we're in condensed form, right? So this is when it's condensed. Condensed means that you have one log statement and the two arguments are separated by multiplication. You take that one logarithm and you take that multiplication, you change it to addition. So then you have two log statements coming from the one. You expand it. So start off here, we went from expanded to condensing. So we see that we have two logs separated by addition. So we rewrite it as one log with multiplication. And obviously we can simplify that and say log base 5 of 28. Okay, go ahead and hit pause, do the second one. Okay, so here you are, you're back. So log base 12 of 4 times 3, that's log base 12 of 12. So remember that in this particular case, if we go back to those rules that we had previously, if our base and our argument are exactly the same, then there's an understood exponent of 1. So just like this rule says if our base and our argument are the same, our answer is our exponent. Here we have an understood 1, so our solution is 1. So when we come back to this guy, essentially what I'm saying to you is that there's an understood 1 right here. So the answer to this is 1. That's what my math method would want you to simplify. Now if we're going the other way, if we have it condensed, we want to pull it apart, we want to expand it. We have three things. We have 5 times m times n. So that means we have 3 logs. So log 5 plus log m plus log n. Remember, multiplication turns to addition. On the second one, we get log base 5 of 625 plus log base 5 of x. Now, once again, this has something that can be simplified right here, and we got a couple of different ways we can do this, and we're going to get into what's called change of base. But for the time being, I'm going to go and pull my calculator up here for just a moment. But what you want to think about here when you're solving this problem is you want to think about how we can apply one of those rules from this previous slide. So how can we apply one of these 4 rules, whether it be a base with a 1, the base where the bases are the same raised to the 1, or where the bases are the same with an exponent. So how can we apply one of those? When we take a look at this, we realize that log base 5 of 5, and we pull out our calculator and just test, that we see that 5 raised to the 3rd power is 125, and 5 raised to the 4th power is 625. So this is actually, we could say this is log base 5 of 5. I'm changing the 625 to 5 to the 4th. So 5 to the 4th is 625. So now, see how my base and my argument are exactly the same? That means that this particular guy is just equal to 4, just the exponent. So we still have our plus log base 5 of x, which we can't do anything with. So plus log base 5 of x. So that's our final solution right there, all simplified up. So we've got a chance to evaluate some of our logarithms at the same time. All right, next one, same idea. We have log base 6 of 36 plus log base 6 of x. So this guy's done. There's nothing we can do to this guy. He's done. However, this one right here, we can see that we have 6 and 36, and so I feel like we can rewrite 36 as 6 squared. So what we did is we rewrote the 36, so that way my base and my argument would be the same. So coming out of this guy, my solution would be 2 plus log base 6 of x. Okay, so we get a chance to actually pull it apart using the product rule, plus we get a chance to utilize our evaluating common logarithms. Okay, so now we pull up the subtraction of the quotient rule. So we got some examples where we're going to expand and condense, or condense to expand. So in the first one we see subtraction. We know subtraction when we condense changes to division. So this is log base 5 of 9 over 3. So that becomes log base 5 of 3, because 9 divided by 3 is 3. this one becomes log base 4 of 20 over 5. That becomes log base 4 of 4. And then remember we learned from our previous rules that means our exponent is 1, which means the solution to this guy is 1. If we're pulling apart or expanding and we have division, this becomes 2 logarithms, so log base 7 of 7 minus log base 7 of 5. Well, the second one's done. There's nothing that we can do to it. But on the first one, we have a base and an argument are the same, so our exponent is our solution. So this is 1 minus log base 7 of 5. So we're evaluating those common logs and we're expanding or condensing. On the next one, this becomes log base 5 of 25 minus log base 5 of 3. So log base 5 of 3 is done. There's nothing that we can do. Oops, I remember the wrong spot. Log base 5 of 3 is done. However, on the first one, this can be rewritten as log base 5 of 5, and we know that 25 is 5 to the second power. So now my base and my argument are the same, so my answer is my solution, or my exponent. So we have 2 minus log base 5 of 3. That would be my final solution. All right. Let me see where we are with time on this video. So a little bit long, but I think we'll be okay. So now what we do is we get more complicated. We go a little bit further into it. And so now we start trying to pull things apart all the way. I'll tell you what, let's do this. Let's go ahead and stop right there. That just runs through the basic properties, and then we can go ahead and do some specific examples. But these are the individual properties when we're expanding or condensing.